Okay, radical equations, the long-awaited video. Now I started with number 2 because number 1 is kind of easy and lame, and I don't want to waste time doing it. So I'm going to dive right into the interesting one. Now remember, the first step of a radical equation was to get the radical alone on one side. Well, it's already alone. So you can dive in and square both sides. Why do we do this step? We do this step because I need to blow the roof off the jail. I have to get what's inside of the radical out of the radical. The only way to do that is to square, because squaring and square root are opposites. So these are going to cross out and you get what's inside, right? You're just basically taking him out of jail. He does not change. Don't do any weird stuff to this thing. You just take it out exactly the way it's written. Now this side you have to multiply. Now, when I walked around the room, I saw a disturbingly large amount of people that could not multiply this. So I'll take my time and do it very carefully. You have to FOIL this, right? First outer, inner last. The x and the x make the x squared. The 5 and the 5 make the 25. I'm going to do that first. And then make the rainbow. You know how I like to make the rainbow. The inner, 5, that's a 5. And the outer, that's another 5, right? 5x and then 5x. So when you combine them, you get 10x. So the inner and the outer always combine to make the middle. So you get 10x there. It's important you multiply that right, because this whole problem is shot if you do this wrong. If you do this wrong, screwed. Do this wrong, screwed. I mean, you're going to factor this. So you have to have the correct things to start manipulating it. Now, as soon as you see x squared, you know that you must factor. So I need to set it equal to 0. So everything on this side has to go away. So let's do it in red to emphasize. I'm going to subtract x from both sides. This is going to cross out. I'm going to subtract 7 from both sides. This is going to cross out. You need to cross them out to put a 0 there. And then just do the subtraction. You have 10x's and you take away 1, is the invisible 1 there. That gives you a positive 9x. Be careful with the signs. $25 take away $7 is $18. That's it, right? You set it equal to 0. Now you're ready to play the game. Factor it. Put the 2 x's. If you see plus plus, then you put plus plus. That's easy. The pair, I mean, look, 18 and 1 won't make 9. 9 times 2 is 18, but 9 and 2 when you add them make 11. So the only pair that's going to work is 6 and 3. And then, as I said in class 40,000 times and continue to say, if the product of 2 things is 0, you heard me say in your mind just now, then one of them must be 0. Solve them. I'll write the 4th grade step there. Right? Get the x's alone. Yay, it's all done. Except I wrote something else over there in anticipation. Remember, these problems are weird because you will get solutions that fail because of this move. The squaring move creates sometimes extraneous BS solutions. So you're going to take the 2 answers you got, and you're going to plug them one at a time. This is important, one at a time, into the original. So wherever you see x, I'm going to put -3. This doesn't take long, but you have to do it, and you have to show it to me. Here you get 7 minus 3, which is 4. And radical 4 is 2. Now, as long as I get 2 on the other side, I'm good. 5 take away 3 is 2. So, yay! This dude worked, so now I'm going to finish putting the box around him. Now I'm going to take -6 and plug it in. Again, wherever you see x, you put -6. Whoops. -6 plus 5. You should already see that it's going to fail. 7 minus 6 is 1. The square root of 1 is 1. It'll help if I can write things correctly. Right? What times itself is 1? 1. But -6 plus 5, if you had $5 and you lost 6, you owe 1. This fails. Not equal. I don't like the way my not equal looks. There we go. It doesn't work. This dude failed. So go back over here, cross them out, and write a BS. Remember, bogus solution. That answer is BS. It just doesn't work. So there's nothing you can do. But unless you check this, you have no way of knowing. When I grade this question, I always grade it as 4 points. 2 points for all that work. 1 point for the 2 checks. I mean, you have to check. And then again, don't forget to reject the answer that fails. All right, now I'm going to do number 3, the easy one. Okay, number 3 is the one where you actually my head's blocking the thing. Number 3 is the one where you actually have to do a little bit of work to get the radical alone. This is what you're trying to isolate. Maybe I'll go green. You know, you need this alone. So anything, you know, it's like if you had 4 times y minus 5 equals 7. You would first add the 5 and then you would divide by 4 to get the y by itself. I'm going to do the same type of moves here. I'm going to add 5 to both sides. Now, I don't want to cross it out because I'm going to, well, you know what? Maybe I'll write the problem again over here for my check, because I know that I'm going to check it at the end. So now I can destroy it. Cross them out. So you get 4 times 1 minus 2x. Remember, this 4 is not inside the root there. 7 plus 5 is 12. Now you have to divide both sides by 4. Right? The opposite of multiplication is division. This is why you divide. You're not subtracting 4. You're dividing by 4. So now you got the radical alone. Yay! 12 divided by 4 is 3. So that was step 1, which you didn't have to do in the previous problem because it was already alone. Now that you get here, and what's nice about this is there's a number there. I'm not going to have to worry about having no x squared dealing and having a factor. So you square both sides. So square both sides. Remember, the square and the square root, they eat each other up, and you just take the guy out of jail the way it is. Remember, you do not change it. You're going to make this a plus. You don't make that a plus. You don't alter it. Just take it out. Just remove the radical. Just take whatever was there and just write it. There was a 1 minus 2x. Just write that down. 3 times 3, 9. And now you couldn't get an easier equation to solve. This is a positive 1. If it helps you, put a little plus there. I have to get rid of that, so I'm going to subtract 1. And then I'm going to cross it out. Remember to keep the negative in front of the x. I see it disappear sometimes when people do this. 9 minus 1 is 8. Now you have a negative 2 times x. Divide by the negative 2 that you see in front of the x. Cross them out. 8 divided by 2 is 4, and it's negative, so it's going to be negative 4. Now, as I said to you in class, when you only get one answer, it's always going to work. You're never going to do this problem and get a single answer, and then that answer fails. They don't work that way. But I am going to check. This is annoying. Now I have to point out again, when you check this, you don't add 5, divide by 4. You have to make sure the left is 7. So you can't do anything to it except plug the number in, plug negative 4 in, and hope that I get 7 on that side. I'm not even going to write the other side. I know that this side, the left side, has to be, right? This is what I'm checking. Is it true? Is this side 7? Put my little dot there. So be careful here, right? You're doing 1 minus 2 times negative 4. The multiplication goes first. So you're going to have 1, a negative times a negative is positive. 2 times 4 is 8. 1 plus 8 is 9. Square root of 9 is 3. Take it out of jail. 4 times 3 is 12. 12 minus 5 is 7. Yay! That's what I have on the other side. So I showed that the left side is 7 when I plug the number in. That's it. Really, it's an easy problem. You might see it on a quiz, might not. Might see it on a test, might not. But the other ones are better because you get 2 answers and you have to check and reject one. So I guess I'll do number 4 now. All right, number 4. This problem gives people fits because first there's a negative here. This is kind of backwards, but this being backwards is really messes with people. So remember, the first move is to square both sides. So let's do the easy part first. When you square this side, just take what's in the radical out. Just take the radical off. Literally, that's all you do. Don't change it. Keep saying that, and I will keep saying that. Now you're going to square the other side. Now, this is where people try to get cute with this. They're like, oh, I'm just going to do x minus 1. Right? Like, you want to put the x first. Don't. Now, will I rewrite it afterwards? I will, and I'll show you. But this is what you're doing, right? You're taking 1 minus x, and you're timesing it by itself. That's what squaring means, multiply it by itself. Don't get fancy here, right? You can do this very easy. This side doesn't change, right? Just leave it there. Just pretend it's not there. 1 times 1 is 1. Negative x times negative x is positive x squared. right? I don't always follow the FOIL. I just do the first dude and the first dude, boom, put that first. I do the last dude and the last dude, boom, put that last. And then I do the middles, right? I make the rainbow. In the middle, you get negative x and 1, that's negative 1x. And then on the outer, right, you get negative x and 1, that's another negative 1x. A negative 1x and a negative 1x is a negative 2x. It's just easier that way, right? The first guy and the first guy make the first guy. The last guy and the last guy make the last guy. And then the rainbow makes the middle. It always works that way. That's how the FOIL works. Just because I don't do, first outer in the last. I mean, it's the same damn thing. The guys in the front make the number in the front. The guys at the end make the number at the end. So it's just easier for me to just do that. And then I do the rainbow. Now, I don't want it like, see, this is where you have to be a little more sophisticated and have some understanding. I don't want this here. I want this in the front. I'm going to factor. I don't need this dude at the end. He doesn't do me any good there. So I'm just going to very carefully take him, put him in the front. I'm just rearranging. I'm not moving, like I'm not subtracting both sides. I'm just rearranging what's there. I can rearrange them and write them in any order I want. Now, I do want this in the middle, so I'm going to leave it in the middle. And I'd rather this be down there at the end. Now, remember, that's a plus 1. I did 1 times 1. That's not a negative 1. So you got to make sure you put a plus there. It's very important that you do that. You're going to have a fit trying to factor this if you don't rearrange the terms so that they are, the way you're used to seeing them. Now play the game. This is a positive 13. You're going to subtract 13. Boom, boom, cross them out. This is a negative 3x. To get rid of this and put a 0 there, I have to do the opposite, which is to add 3x. Again, be very careful with your signs. Here you subtract 13 because it's a plus, right? There's a plus there. You don't write the plus, but there's a plus. There's a negative there, so you have to do the opposite of it. They cross out and they make the 0 that you want. You want a 0 here. So now you have x squared. Now be very careful. Positive 3 take away 2 is a positive 1x. And then $1 take away $13 is negative 12. All right. If you screw up any of these steps, the problem is shot. You're going to get here and it won't factor. And then you're going to stare at it, but it doesn't factor. If it doesn't factor, you made an error. The only technique you know right now to solve an x squared thing is to factor. And they're designed that way. I'm not going to give you one of these problems that doesn't factor. You're going to use the quadratic formula. I mean, it's ridiculous. This will always factor. So they're designed that way. So let's do our signs. That one goes first. The signs are different because the last number is negative. And then, you need a pair that makes a 1. It can't be 12 and 1. When you subtract 12 and 1, you don't get 1. It can't be 6 and 2 because when you subtract 6 and 2, you make 4. So the only pair that you can subtract that makes a positive 1 is 4, take away 3. 4 times 3 is 12. Positive 4 minus 3 is a positive 1. So then again, if the product of two things is 0, one of them must be 0. And I'm running out of room at the bottom there. So I'm just going to put it up here, right? Subtract 4, add 3. If you want to see it, people yell at me, you skip steps. So I get x equal negative 4 and x equal positive 3. Right? You cross that out from that side, right? X, that x is alone now, equal negative 4. So we're going to check. I'm going to go back to the original. Wherever I see x, I put negative 4. I should have wrote this bigger. You're going to get 13 minus 3 times negative 4 equals 1. I have to write that again. I wrote it very badly. 13 minus 3 times negative 4. Replace that with negative 4 equals 1. Now be very careful here. 1 minus, now x is being replaced with negative 4. It's very, very easy to F this up, right? The 1 stays, the negative stays, the x itself got replaced with negative 4. That was an x. So now on the inside, because it's very easy to do a mistake here and then think that this number fails. Negative 3 times negative 4 is positive 12. 13 and 12 make 25 when you add them together, right? 13 and 12, add them up to get 25. Square root of 25 is 5. Now, on the other side, this negative and this negative eat each other up and make a plus, right? Two wrongs make a right. A negative and a negative is positive. But 1 plus 4 is 5. So that checking that number is really tricky. You screw the sign up there, then you're going to be like, it didn't work. And then you're going to reject it. And the problem is 3 is going to fail. So then you're going to think they both don't work. So you have to be really careful with the signs there. So this time the negative number worked. Now, when I plug 3 in though, you know, you're going to get something nice on this side. Put 3 with the x's. Now, the other side is 1 take away x. 1 take away, now what's x? 3. This is what kills it. Because you can't, the square root is never going to be negative. So you're going to get 13 take away 9 on that side, right? 3 times 3. 13 take away 9 is 4, and square root of 4 is 2. But on this side, 1 take away 3 is negative 2. And this is just false. So this will always happen. You'll see that one of the sides, you know, comes out to be a negative. And the radical is always defined to be the positive root. You know, the square root of 4 is not negative 2. Square root of 9 is not negative 3. You know, this isn't how it works. The square root is always a positive number. So this dude failed. So we write BS on him for bogus solution. This dude worked. So all we got is one answer. Negative 4. It's a very tricky problem. So many places you could screw up. You could screw up here in the beginning, multiplying it out. You could screw up setting it equal to 0. You could screw up factoring it, and you could screw up plugging in to check it. I mean, there's a lot of little places you could make a single sign mistake, and then the whole thing is going to be shot. So just again, when you do these problems, I'm not going to do anymore because they're just repetitive at this point. Watch your signs, take your time. Don't fly through it. You know, the check you can do, you know, a little quicker. I mean, this check was easy, but see, this check you had to take your time. So the important thing is don't rush through the problems. Take your time, pay attention to what you're doing. Make sure all your signs are good. It's not that bad. But again, don't skip the check. You skip the check, you're going to lose 2 points out of 4. And that's a lot. All right. So good luck with these.